This is Dan Abbott. I'm going to review the navigation instruments on the boat we use for the Southern Maine Community College Seatime class. And I'm on the boat right now. It's obviously kind of windy. You can see the flag on the left there, headed directly into the wind. This is a good idea when you're trying to hold station. And I was trying to just sit still for a while so I could make this video. Looking at the compass, this boat has a combo compass where the compass card, which is this part right here, can be read from the front or can be read from the top. It's different when you read it from the front to the top in terms of the apparent direction that the compass headings go. So if you take a look at this, there's 240, 250, 260, 270, 260 right here. You look up there, you're reading it from the other direction, 240, 250, 260, slightly more. The compass is giving you the heading magnetic. Magnetic and true are not the same in most places. There are some places where the compass happens to be sitting directly over a flex line that does in fact result in pointing to true north. But most of the time you have to compensate for the fact that the compass itself is reading magnetic and not reading true. Something to note about a compass. The framework of the compass is here, and then that little bubble. The card is free to pivot on that little needle right in the center. That means the frame of the compass is bolted to the boat. As the boat turns, the frame turns, and the card stays aligned with the magnetic flux lines in the earth. Now, I'm going to back up just a little bit. The reason I have a compound compass is so that anybody who gets in the boat, no matter what kind of compass they're used to, can read that compass. Now what I'm going to do is start to make some turns. When I turn to the right, the compass headings are going to increase. When I turn to the left, the compass headings are going to decrease. Going clockwise is how angular measurements on the ground increase. Looking straight down at the top of the compass card now. Now we're looking at the front of the compass card. Now I'm starting a turn. If I can get it steady down. You notice the numbers are getting bigger. They're getting bigger. They're getting bigger because I'm making a turn to the right. So I've gone all the way from 260 past 0 to 030, still getting larger, all the way up to 060. And you notice in the back, the top reading part of the card is reading the same thing, but the numbers themselves appeared to be getting larger from the opposite direction because it's on the opposite side. Those lines, by the way, are called lubber lines, the yellow. That just shows you how to align the compass. So right now we're at 070, both in the front and in the back. You notice to the left of 070 is 090 in the front, but up here is to the right where you have east, which is the same as 090. Now I'm going to turn the boat the other way. I'm going to the left now, and you can see that from the bow. As I turn left, the values are decreasing, both in the front and in the back. But again, they're going in a different direction, apparently in the back, because you're looking at the top of the card at the back instead of the front of the card in the foreground. Holding a compass course is a little bit tricky. You can see I'm holding a camera and trying to steer the boat at the same time and keeping my eye out for other boats, which is why I am sitting in Portland Harbor, someplace where I'm out of the way. But you can see the card moving back and forth apparently, but it isn't. The card is staying put. It's the boat that's turning under the card. So as that is decreasing, I'm making a left-hand turn, left-hand turn. So I'm turning the frame of the compass to the left or counterclockwise while the card stays put. Now we're going to take a look at my chart plotter. This chart plotter is a Garmin chart plotter. It's got a GPS. The triangular piece in the middle represents the boat. If you take a look, I am in Portland Harbor on the South Portland side near the tanks and near South Portland Pier. You look up, there's South Portland Pier. The accuracy of GPS chart plotters these days is extremely high. if I zoom in on this, which I can do by using the zoom buttons, seems it's a little shaky just because I'm trying to do this. Well, there we go. So at the upper right hand corner, let's just go back and take a look at that. In the upper right hand corner right here, we have a button for zooming in and another button for zooming out. You have a few other buttons here as well. The button for zooming in just gets us closer and closer, so it would be easier to see what is exactly going on here. Zooming out gives you a larger area. Continue it now. Alright, now what I've done here, just back up a little bit. What I've done here is I've pressed the button on the GPS that is called, let's see if I can get it here, right there. The page button right here. You press that page button, it cycles through various pages on the GPS chart plotter. The next page it's going to cycle to is going to have some information, some data. That data, when I press the button, is our lat long and our speed, and that speed is in knots. That speed is over the ground, it's not through the water. The lat long is given here, and anytime we're in Maine, we're going to be in northern latitude, we're above the equator. We're also going to be west, because we're west of the Greenwich mean line of longitude. On the radio, when you give this as a position, if you have to do it, you would say north 4-3 degrees 39.171. You don't need to indicate minutes. And then west 070 degrees 14.633. If I were really doing this in an emergency, I wouldn't bother to say north or west, because if they can hear me on the radio, we are both north and west. Also at the top of this, it shows you, and there's my speed, and I'm in Portland Harbor, so I'm trying to take it easy. At the top of that page, you can see that it gives you a heading. I don't usually use that, but that's sort of a compass heading, but it isn't really compass. That's really just the direction your boat is going as it moves. So very often that number at the top is not going to correspond to the number on the compass. And the compass is what you want to rely on. Compass is always right. Go back just a little bit. Yeah, so this is telling me not the heading of the boat. If I was sitting still and I turned the boat, that wouldn't change. It's always based on the movement of the boat in the recent past. What else is there here? Enter mark is if I want to mark something on the chart. Tarbox Rock, for instance. And MOB stands for man overboard. And that's one of those buttons that's there, so if you press it, it automatically drops a mark on your chart plotter. And the idea here is if you hear that there's a man overboard, you press that button and then you know you can get back to where you were when you heard it. That's the power button. It also controls how bright the light is if you're using it at night. This little window here, and most GPSs will have something like this. If you open it up, there's a little card inside, and that card has the charts, in this case the charts for northern New England on it. I have another card for the charts for New York State, because I took the boat down to the Hudson River one time. So you can get, for any of these chart plotters, you can get various charts for the different areas you might be boating in. Over to the right, we have a depth sounder. In this particular case, it's not just a depth sounder, it's actually a fish finder. You can see on the bottom, it shows you what the bottom looks like under the water. And you can see in this case it's fairly smooth. You can also tell something about it. If you take a look at what it looks like, I can see that that's mud. I can also tell that it's not rising or falling very, very fast. But one thing to keep in mind about this, and the depth of the water is 38.2 feet. Now that's the depth from the transponder, which is the part that sends signals out and then gets the return back to figure out how deep something is. That transponder on my boat is connected to the transom. It's down near the bottom of the transom. So it's really telling me how many feet of water are there beneath the lower part of the transom. It's not from the upper part of the boat, it's from the lower part of the boat. That means that even though we might say have 2 feet of water, the amount of water that would be demonstrated here, the amount of distance here, would be down to say 1 foot. Under my transponder I have about 11 inches of motor. So anything that I see here, anything below 3 feet concerns me because it could change fairly quickly. But anything above 1.5, 2 feet means we're actually still floating. Some boats, by the way, have a single gauge that has nothing but the depth. That's fairly common on sailboats. This also, it's called a fish finder because if there were a school of fish under there, we would see that as well. You can see we've got something under here, probably just floating vegetation. This can also be changed. The menu can be changed. And the menu can be changed so that it shows you other information other than just depth. Now I'm traveling along and you can see that the depth is changing a bit. And then once it gets to a certain point where it's a little deeper than it had been, now it changes the range. So now it's at the 60-foot depth, which means the total depth available is 60 feet. And it shows you the bottom. Looks like it's a little bit shallower, but in fact it's because it's deeper and it just changes the scale that's being represented. You can still see, though, that the bottom itself is fairly flat. The darker the return on this is a grayscale fish finder. The newer fisher finders are color. I don't have one because they cost a lot more money. And I don't like to replace electronics until it stops working. But the lighter the gray, the softer the bottom tends to be. In this particular case, the bottom is hard, but it doesn't probably have rocks in it because you can also see that it's smooth. The other thing to concern yourself about with a depth sounder is that the transducer is on the back of the boat, which means it doesn't tell you where you're going or what the bottom looks like ahead of you or the water depth ahead of you. It tells you what the water depth is at your stern. Now there are some depth sounders that are forward reading sonar, and they show you what you're approaching, and that's very helpful, but again, they're very pricey, so I don't have one. There's a low rance, by the way, fairly typical type. What else am I going to show you here? I originally was talking when I made this, but it was so windy that it was noisy, so I decided to just talk over it. Okay, now you can also change the display. So what I'm doing right here is changing the display. I'm changing the display so that it goes right here, display mode, and then I start moving it up. Now I can get both the depth and the water temperature, and if I keep going, I can get the two of them much larger so that I can see what the depth is a little more easily. I frequently do that and then switch back to something that shows the bottom if I need to see what it is. If there were a school of fish, we'd see a lot of little black dots around. Again, on the color depth sounders, the color itself tells you something about the density of what the sonar is hitting. So they're nice to have if you're fishing, but I don't really fish, so I don't need that. It's just more for me to know how deep the water is. No, I don't know why I'm back here. But at some point, okay, now we're looking at the electronics I have above. It's under the T-top. This is a VHF radio, and let's stop it right there. It's a VHF radio. Where I have my thumb is this little red window. That little red window covers the distress button. This is what's known as a selective, digitally selective 8 VHF radio. That means that when it's turned on and it's getting a signal that indicates it knows where it is with the GPS lat long, if I press that button, since the radio has been registered with the Coast Guard, it will get information about the boat, the size of the boat, the color of the boat, the owner of the boat, the name of the boat, and it will get an indication of what my position is. The only time you'd ever do that is if you were in serious trouble and you needed help from the Coast Guard. So you lift it up, you press the button. Don't ever do it until you need it. Over to the left, right. Sorry about the movement, but it's not as easy. No. The microphone, as you can see, is right over here to the right. That microphone is what you would key, and there's the button right there if you wanted to talk on the radio at a certain channel. I don't have it turned on right now because I was making a video. I didn't want the sound to interfere. But now on the left, I have right over here another GPS. It's not a chart plotter, it's strictly a GPS. And I have it there so that I can connect it to the radio, and then the radio can give me the lat long. So here I've turned it on, and what it's doing right now is acquiring satellites. I'm going to stop this just for a minute. Those bars indicate that it located 1, 2, 3, 4, 5, 6 satellites. Now there are 25 satellites orbiting Earth at any given time. It shows me here where they are. You don't have a sight line to the satellites, all of them. So what it wants is at least 3 in order to figure out where I am. The more it has, the better. It's located that the satellites exist, but it hasn't actually started picking up a signal for them. So it doesn't have any idea right now where I am. If we wait a little while, it will acquire enough satellites to give a position. So a little hard to read because of the reflection. Of course, it's reflecting me in my PFD here. This is also giving me the speed. The lat long is right here, just in the same format, north 43 degrees, and then some number of minutes. And it's also in decimal minutes and not in minutes and seconds. Now, whatever it's reading here is going to be broadcast to my radio. So it's broadcasting 43 degrees 39 decimal 207, 70 degrees 14 decimal 549. Take a look at the radio now. I turn the radio on, and the radio is going to right there it is. The radio is going to display, let's go back to it. The radio is going to display the same lat long. It only displays it to 2 decimal places, but that is plenty if you're trying to tell the Coast Guard to come and get you. And that's what's going to happen. That would be then broadcast to the Coast Guard. A few other buttons here. I won't go over all of them. Turn on, off, and volume, and then you have something called a squelch over here. The squelch is used to set the sensitivity of the VHF. What you do is turn it down until it makes a big noise, a squelch, and then you turn it right clockwise until the noise stops. Pressing 16-9 toggles between channel 16, which is the emergency channel, not a channel. It's not a hailing channel anymore. It used to be considered that. People still use it for a hailing channel, which means they get on 16 and call their friends, but usually they then transfer to a different channel. 6-8 is the most common, just sort of an open communication channel. Coast Guard will sometimes come on when you do that and say 16 is an emergency channel. Hailing channel is now number 9. People just haven't gotten used to that yet, so it hasn't happened. And now I'm back to sort of showing you Portland Harbor as I go through. Got a few. First is the tachometer. Tachometer tells you how many RPMs the motor is turning at any given time. So this is 7 times 100, or 700 RPM. My tach also shows the number of hours that are on the motor, although it's not really accurate because when I bought the boat it didn't have an hour meter on it. The tachometer was broken. I didn't replace it for some time. So that number right there is real number would anywhere from 1,500 to 1,800 hours. I don't know exactly, but I do know it's quite a bit, and it's quite a bit for an outboard motor of this type. You've got a temperature warning and you've got a low oil pressure warning. They look like they're on right now, but they aren't. That's just the sun hitting them the way they are. There's another gauge in my boat that also didn't work when I bought the boat, and I've never bothered to replace it because what it would give me is the speed through the water. I can get the speed through the water from my depth sounder, so I don't really need to know that. So the other thing at the helm, these are the switches, and that's really just an electrical panel. The switches are all labeled here, a little hard to see, but accessory controls the trim tabs, electronics controls all the electronics in the boat. There's also a bilge pump here. There's also a horn. You flip that over and an air horn blows. It'll blow as long as the switch is on, so you can do a prolonged of 4 to 6 seconds, and you can do a short blast of 1 second. Then you've got the nav lights in the front, and you've got the all-around light above. So the lights are controlled here. The horn is controlled to the first one. It's not a push button, so if you turn it on, you've got to then turn it back off. The electronics, that little button right there, and what you have over here is lights that go on, and they also have fuses behind them. The helm has a steering, and the steering in this case is hydraulic. So what you've got here is a reservoir of hydraulic fluid and a pump. As you turn the wheel, it pumps one way or the other, and it pushes fluid to the back where I've got a piston that turns the motor. That little door, that little button right there. When you screw it off, that's how you put fluid in. Fluid's hydraulic fluid. It does lose fluid over time. That's why I have a little band here to kind of soak up any little drops that come out. I have to replace the gasket and sometimes even the whole helm, but I've had to replace the helm twice since I bought it. And I have to replace a gasket every couple of years or so. But it's a really nice, smooth, easy way to steer a boat, so I really like having the hydraulic steering. There's a little better view without the wheel in front of it, so you can see that it's actually labeled. And at night those light up, so you can just barely read them. A couple of switches right here. As I'm doing training with the class, I'll be more and more encouraging you to use them, but for right now that can be a little confusing. They're called trim tab controls. There's a left one and a right one. Trim tabs are metal plates that stick out of the stern. When they're in the neutral position, they go straight out, so they don't have any effect on the trim of the boat. But the one on the, well, one of them, when you press that button on the top, drops the left bow of the boat so that it can even up when it's not quite in trim. If you press the bottom of it, it lifts the left bow of the boat. Over here, press that button there and it lowers the right bow of the boat. Press the bottom and it lifts the right bow of the boat. And it does it by controlling them independently. When you drop one of them in the water hits it and pushes the stern up on that side. If you put them both all the way down, it tends to trim the bow down but leave the boat so its side to side trim is the same. Right here we have a spinner, speed knob. It's shiny, which is why you can see me in it. They used to put these on cars. It's illegal to put them on cars now because cars react so much more quickly to any change in the position of the steering wheel. But on a boat, you're frequently changing the position of the outboard quickly from one stop to the other. So you're going hard right rudder to hard left rudder. And you do that when you're maneuvering a boat in small places. I really like having it. It makes things a lot easier. On my boat, it's not likely to cause a problem that it would in a car because the reaction time on a boat is slower than a car, and my boat in particular, because it has a flat bottom, has a tendency to slide. So even if I make a really dramatic and quick change with that, it's not likely to throw anybody off the boat or dig in. You can see how this works. When I go through, you grab it, you can turn the wheel the other way. You can see how quickly you can do that. Now the trim tabs are one way to trim the boat, but on the side of the controller, and this is both the shifting controller and the speed controller, on the side is a little button. One says up, one says down. This tilts the entire outboard motor, either tucking it in or pushing it out. So when you press the button on the top, the motor tilts forward by pushing the prop back. And when it does that, it has a tendency to push the stern down, which in return puts the bow up. Go the other way and it tucks the motor down where it's up under the boat a little more, and now it's pushing the stern up, which tends to push the bow down. So you don't have to use that underway, but it's very helpful in terms of keeping the boat so it's as level as you can get it. And sometimes you don't want it level, you want it to bow up slightly because it goes a little more efficiently through the water that way. Another gauge on the boat we haven't looked at, and that's the gauge down below the tachometer, and that's the gauge down here that measures the electrical output in volts. The electrical output in volts is there to tell you whether or not your battery is being charged while you're underway. I don't know if we can get a little clearer picture of that or not. Yeah. So 12 volts, it's a 12 volt battery. So in order to be getting charged, that needle has to be past the 12. Ideally 14. This is essentially like having it, this is what a brand new motor would be. I did have to replace the alternator in the motor one time. It was some years ago, but as a result now it charges all the time while the motor's running. That's a good thing, so that when I go someplace and turn the motor off, I can start it again. I also, however, have two batteries on board, one deep discharge and one starting battery, and I have a booster pack, the kind of thing that the AAA carries around with them, so if they go to help somebody whose battery is dead, they don't have to do jumper cables, they just take the booster pack out. And I carry that with me primarily because when I was in the auxiliary, dead batteries were the most common cause of people not being able to get home. and having one of those with me meant I could just hand it over or go over with it, connect it to the battery of a boat that was disabled. They could start the boat, and they could get home. Two more things. One is this is both the throttle and the shifter. Unlike many pleasure boats, it does not have a safety in the handle, which means you can go from full forward to full reverse on this if you can get it to do it. Dangerous to do that. It's going to ruin the transmission and the outboard motor. It's also going to throw people around. The key thing in this when you're driving this boat, right there where you have that little rounded place, that's clutch speed going forward, and it shows you up goes forward. Now this remote sticks straight out of the helm. That throws people a little bit. They're used to sometimes one that's mounted on top, so it just feels a little different because what you're doing is moving the lever up and down instead of forward and backward. When you do that, you want to go from neutral, which is when it's lined up right here, and snap it into place. Don't take your time and grind the gears. You just snap it right up there where that little round is. Then there's a fairly long distance from here to right about that part there before it starts to actually accelerate. Reverse, you do the same thing, but you go down. That little round spot on the bottom is clutch speed. Snap it in place. And by the way, clutch speed is 700 RPM, so you can see I'm in clutch speed right now. Because I'm taking a film, I'm on a boat. There's no other boats around me, but I'm keeping an eye open. But I'm obviously not going to do a film like this going 1400, 2800, 4200, 5200 RPM so that I can make sure nothing goes wrong. So that is clutch speed. When you go into reverse, you take it out of forward, stop or pause in neutral, wait for that RPM to drop back down to 7, because if you've got this ahead, you're going much faster than 700 RPM. Snap it into neutral, pause, wait for the RPMs to drop, and then snap it down into reverse to change directions. So you take your time when you do that. And the thing you don't want to do is make any sudden big changes in forward to reverse. Same thing on the bottom as you have on the top. You can go about halfway before it starts to accelerate, and you just need to experiment a little bit underway when you're at the helm to figure that out. And the last thing I want to show you is this is the ignition. Now it's turned on right now. You can see that it's generating electricity. You can see that the motor is running. The yellow thing I have here has got my registration in it. It floats. That means if I drop the key somehow, I'm going to still have my registration and I'm going to still have the key. You start it the way you used to start old-fashioned cars before they had start buttons. Old-fashioned meaning, 10 years ago. I've actually driven a vehicle, I've been in a vehicle where you started it with a crank in the front. This little cable that comes off of here, that's a little wedge that sticks into a button right here. And that button right there is called a kill switch. If, when you have this connected to your belt loop, you fall off the boat, that unsnaps that, it pulls it away. That switch closes. When it closes, it turns the motor off. And now if you happen to fall in the water, you don't watch your boat driving itself away with no one at the helm. You're required now by the Coast Guard, if you're on a boat that does not have a cabin, you're required to have that attached to your body. And I do that when I'm alone every time. I often do that even when I've got people with me. When we're changing people at the helm and going back and forth, I will often put that on myself, but not necessarily have you put it on this boat. Because you've got a T-top, because you've got a center console, you're quite a ways away from either side of the boat. Chances of you falling over are pretty slim. But that's one thing you would always want when you have a boat that you're operating by yourself. At least that's something I would always have. And that's the whole sort of covering of the boat. There's a power outlet here, which is the kind of 12-volt power outlet that cars have, where you plug something into it and then you can have an extension that goes to something else. And that's it, although you can, right down here you can't quite see, but there's a strap there and there's a battery box. There's another one beside it. So I have two battery boxes and a big switch under there that switches between the batteries.